This is section 4.1, and we're starting chapter 4, and we're going to pick up more nonlinear functions, various kinds, in chapter 4. So let's look through these. Start out with polynomial functions. The domain of a polynomial function is all reals, and its graph is continuous and smooth without breaks or sharp edges. The degree in the polynomial is the highest exponent. So let's look at some examples of polynomials and talk about the degree and leading coefficient for each one. So f of x equals 10. If we didn't have this x to the 0 here, because I wrote that in as understood, so you just have a number here. The degree is 0 and the leading coefficient is 10. I also wrote this 1 here because we don't put a 1 on the ones that are linear like that. The degree is 1, leading coefficient's 2. In this one, the degree is 2, that's the highest exponent, and the leading coefficient is 3. Now, it's not in the order we're used to seeing, but you still have to find the one with the highest exponent, and its coefficient is the leading coefficient. In this k of x, its degree 6, and the leading coefficient is -1/2. This statement is really, really important here. The exponent in a polynomial function cannot be negative, fraction, or radical. So these are examples of things that it cannot be. Can't have x to the -3rd. You can't have x to the 1/2. You can't have x to the square root of 5. So keep that in mind. All right, let's talk about absolute and local maxes and mins. So when we have these polynomial things, so here we have a parabola. Here we have a 4th degree. So in this one, the absolute minimum, the absolute lowest point is -6. Now the ordered pair is 2, -6. But if they ask what is the min, it's -6. It occurs at x equals 2. The absolute max, it doesn't have one. Those arrows indicate it's going up forever. Okay? All right. In this picture, we have the highest point of the picture is right here. So the absolute max is 12.7. The absolute min, we don't have one. But we do have some local things that between two other places, it's either a low or a high. So a local max is right here. See, we're going up and then we're down. So that's kind of a local max, and that's 2.25. The local min is -3.1. So you can have locals and absolutes, and that is certainly a possibility. All right, now let's talk about symmetry. We have even functions and odd functions. Even functions are symmetrical with the y-axis. That means on either side of the y, they are the same graph. And if you have the exponents, they're even numbers. Odd functions are symmetrical with the origin. That's a little harder to think about or see, but think about if this was a spinner, like a board game spinner, and here's the center of the spinner. If you spin this 180 degrees, this high point becomes the low point. This low point becomes the high point. So if you spin them 180 degrees, they become the same graph. So that's one way to think about it. The exponents, they will be odd numbers. And so that's the difference. Now, if they're not even and they're not odd, we just say they're neither. And you will have some questions on that. All right, let's go look at our problem sets for these. All right, here are our problems. The first one says determine whether f of x represents a polynomial function. So we want to remember the parameters for that. If it is, we talk about its degree and leading coefficient. So we don't see anything here that's a problem. So this is polynomial. The degree is 5 and the leading coefficient is 1. All right, number 2, same thing. But here we've got the 5th root of x. Anytime you're taking a square root, a cube root, any of those, that changes to a fractional exponent. And so we said that we can't have that and it be polynomial. So anytime you see the square root of x or any root of x, it's not going to be a polynomial function. Number 3, no problem. The degree is 5. The leading coefficient is -2. On number 4, so this says 1 over 9 minus x. And if you're just thinking about x, you might say, well, there's nothing wrong with that. But that's on the denominator of a fraction. So the best way to see it is to graph it. Go in your y equals on your grapher and have 1 divided by, and in parentheses put 9 minus x. When you do, you get this graph. And remember, one of the definitions was it's a continuous graph. A polynomial is, it has no breaks. Well, this one definitely breaks. So it's not a polynomial. Number 5, g of t is 25. It's understood that that's x to the 0. So that can be polynomial. The degree is 0. Coefficient is 25. On this one, we're now going to be talking about maxes and mins, the local extrema. That's what it's talking about. So it wants to know the y values when it says the local extrema are. So this point is a min, so that's a -4. This is a local max at y equals -1. All right, on this one, they're asking you several questions about this graph. So I highlighted the arrows telling you it goes on forever, and then I did the highs and the low points. Estimate the local mins. Well, you have one here at -14. You have one here at 0. Estimate the local maxima. So you've got one here at 6, one here at 8. And notice those are going by 2's on this y-axis. What is the absolute min of f? Well, this guy's going all the way down to a -infinity. There is no absolute min. And the absolute max, that yellow arrow indicates there is no max as well. All right, number 8. Find the numbers at which f has a relative max. And then what are these relative max? So the first one, it says find the numbers at which it has that. That means these are asking for the x value. So if we have a max, it's right up here, and the x value, the number at which we have that, is 3. And then the max value is 5. The numbers at which we have relative min, well, that's x is 2 and x is 4. And then the y values there are 1 and 1. And you do need to list those separately. So when it says find the numbers at which it has it, that's an x. And then what are the maxes and mins? That's a y value. All right. Use the graph of f to estimate the local extrema and absolute. Now, there's a really good, let's highlight this. Okay. Local extrema cannot occur at endpoints because they only occur on open intervals. So if you have just an endpoint, it's not going to be a local extrema. All right. Estimate any local min of f. So here, right down here, and we don't know that exact number, but we know it's between 2 and 3. So it makes sense it would be this -2.6. Local max, there is not a local max. There's a high point, but it is at an end point, so we can't use that. There'll be no local max. Estimate the absolute min. That's going to be that same -2.6. And estimate the absolute max. That's up here. This can be an absolute. It just can't be a local. And it's between 8 and 9, so 8.4, we're going to go with that. Number 10, list the values at which f has a local min. So down here, that's x equals -9, and over here would be x is 3. What are these local mins? Well, that's down here at -9 and -9. Okay, so that's how we're doing that. When it asks, sometimes it asks for the x's, sometimes the y's. 11, determine graphically any local and absolute extrema. So you will go to your y equals and put this in. Let me pull the grapher up. I mean, this is the picture, but I'm going to go over how to find that. Let me get that up for you. Okay, I pulled that up and put in our x squared minus 3x minus 4. I'm going to do a zoom 6. That's a standard window, and that's good. We can see the minimum part. So we're asked to find that. We're going to do second calc, choose minimum, which is number 3. And on the screen it says, where's your left bound? So you want to use your left and right arrows on your wheel here and go to the left of this lowest point. I'm already there, so I can hit enter. Then it says go to the right bound. So I got to use my right arrow and go till I'm to the other side of that lowest point. That's about right. It's fine wherever you stop as long as you're to the right of it. Hit enter. Last time it says guess, you just hit enter without moving. And you have 1.5 and -6.25. So that is the min, and this wanted the y value. So -6.25, and it does not have a max. It says type an n if there is no absolute max. All right, we do the same thing with 12. You would put this in your calculator, and you would find the local mins. And let me pause and get that up. Okay, so I've got that one up. One thing to be careful when you're putting it in the calculator, when you have to do these exponents and you do use your caret here, so to the fourth, you would hit that and then choose fourth. Be sure you hit your right arrow to bring it back down, because a lot of times I'll forget that and I'll have everything up here in the top and have to do it over. All right, so it wants to know the local min. Let's do a graph. And we can't see all of this. Let me put you on pause and get a good win. Okay, so I played with it a little bit and made my y max 30 and my y min -20, because the -10s and 10s weren't working. You just have to play it. You want to see everything. So the local min right here, let's see if we can find that. So second calc min, and I need to get back over here and hit enter, and then go to the right, hit enter, and enter, and I get -14. It says round to the nearest integer, so we would just put -14. So that goes there. The local max, there's two of them, so let's do that. Second calc max, and I want to go to the left of this high point, so right about there, enter, over to the other side of it, enter, and enter. And so that's, if I round that to a whole number, that's -10. And you would do the same for this one. If we do second calc max, but before we start doing anything, we need to get all the way over here. So enter, go to the right of it, enter, and enter, and we get 20. So that's how you would do those on the calculator. There is no absolute min, if I pull that back up, because that goes on and on. absolute max is 20. So graph that, sketch it, have it there for yourself to be answering that problem. Number 13, use a graphing calculator, and this is a cubic, but you would do the same thing. Put it in y equals, and then find the max like we just did, round it 3 places, find the local min. These are y values. All right, number 14, we're just looking at this to see whether it's even or odd. Is it symmetrical with the y-axis? No. Is it symmetrical with the origin? No. So this is neither. 15. Is this symmetric? Yes, it looks like it's symmetric about the y-axis. So that means that it is even. Number 16. Determine if this is odd, even, or neither. There was no exponent here. It's an understood 1, so that makes that an odd function. 17. We had 5x plus 4, so there's an understood 1 there. There's an understood x to the 0. 0 gets thrown in with the evens, so you have 1 odd, 1 even. That makes that neither. You got to have all the same. And this one, we've got 4, 6, and an x to the 0 there, so they're all even. So that one is even. So I think that will get you going on 4.1.